So more integrals involving trig functions. Now we're going to see integrals that do involve sine and cosine together. But the difference is both sine and cosine are being raised to a power higher than 1. So as I've said before, if one of those functions is being raised to a power or being operated on, and the other one isn't, then it's very easy to use that one as du and rewrite the other one in terms of u, like this example here. But what if, like is shown here, what if we have sine raised to some power m, where m's greater than 1, and at the same time being multiplied by cosine that's raised to an n power where n is a power higher than 1. In other words, it's not a straightforward u substitution. Well, again, there are two cases to this, and again, the cases hinge on whether our exponents, our powers, are even or odd. So the first case we're going to look at is when one of our powers is odd. If at least one of our powers is odd, it turns out that, again, we're going to use the peel one off method. So let's do that. Let's peel one of these sine factors off, and I'm going to put it out here at the end. I wanted to do an example also where you could see a negative exponent, because I didn't want you to get the idea that this only works for positive exponents. So I peeled one of the sine functions off. The reason I did the sine function is because it is the one that is odd. If both cosine and sine were raised to an odd power, it wouldn't matter which one I used to peel one off. So now what I'm going to do is I'm going to just use that Pythagorean substitution that I know from trigonometry, and I'm going to substitute sine squared of x and put it in terms of cosine, because again, it's my hope to force this to be du, meaning I need everything else in terms of cosine, so that when I take the derivative of cosine, du will be in terms of sine x. So now I'm just going to distribute this term through those parentheses. So I get a cosine to the negative 4 of x minus, now cosine raised to a power of 2 times cosine raised to a power of negative 4. When we multiply the same bases, we add the exponents, remember? So that's what that's going to turn out to be. And then I still have my sine x dx here. So now I have it in a form where it is a u substitution problem. If I choose u to be the cosine of x, then du will be the negative sine of x dx. I can completely rewrite my integral in terms of u. It is a power rule for integrals now. That's the form it's in. And don't forget, I'm off by a negative, so put your negative out front. So now I just find my antiderivative. It's 1 over n plus 1. Negative 4 plus 1 is negative 3, so there's the coefficient there. U to the negative 3 minus, and what I'm going to get here is negative u to the negative 1. And then plus c. So we'll kind of need to watch all of our negative and positive values here. This turns out to be a positive 1/3 cosine of x raised to the power of negative 3. And then I have a negative, 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 so that's a minus cosine to the negative 1 of x. It might be better to write this as secant of x, because cosine inverse does not equal secant of x. And when we have this, when sine and cosine and functions like that show up, we usually read that as inverse and not to the power of negative 1. So I think I would actually write that when I back substituted in terms of my original variable. I think I would write that as the secant of x. That would be more straightforward. But there we go. There is, if either m or n in your integral are a odd power, if m or n are an odd number, then we get to use the peel one off technique that we saw in the last set of videos. Let's see, let's move forward. And here's the second case. What if both m and n are even? Well, we're right back to our drawing board like we were before, and we're going to have to use those two substitutions. Here is the sine of x squared times the cosine squared of x squared dx. So I'm going to have to use those, sorry, that should be there. I'm going to have to use those substitutions. So we have 1/2 times the quantity 1 minus cosine of the double angle, and that's a substitution for sine squared. And then we're going to have 1/2 times 1 plus the cosine of the double angle measure, but that gets squared. This equals cosine squared of x. This equals sine squared of x. All right, so now we've just got a lot of algebra to do. A lot of algebra to do. So let's go about trying to do that. I am going to, again, get these fractions out of my way. 1/2 squared is 1/4 times 1/2. I have a 1/8 out front. And now I've taken care of all of my fractions. So what I have, I'm just going to copy this down. And then I'm going to FOIL this out and multiply it by itself. I just do my algebra in steps. So I have 1 plus 2 cosine of 2x plus cosine squared of 2x dx. And now we can multiply through again, 1/8. And I'm going to take this term and multiply it by every term out here. So that's where I'm getting this from. Plus cosine squared of 2x. So that's where that comes from. Now I'm going to take this term, this negative cosine of 2x term, and multiply it by all three of these terms. So I wind up with negative cosine of 2x times 1. And then I'll drop down here, minus 2 cosine squared of 2x. That's this term and that term. And lastly, a minus cosine cubed of 2x. And that's dx. I could gather like terms. I have 2 positive cosine 2x's, 1 negative cosine 2x. So let's gather like terms here. That's a 1 plus 1 cosine of 2x. I have 1 positive squared, 2 negative squared. So that gives me a minus 1 cosine squared of 2x. And then minus cosine cubed of 2x. And all that is with respect to x. Again, there are 2 of these that I can go ahead and find the antiderivative to. But I'm not going to do that. I'm going to just keep going and try to put everything in its most simple terms, do all the substitutions that I need to do, and then we can find the antiderivative. Now, I've got another substitution I'm going to have to make here. This is a substitution where I'm going to have to do the 1/2 times the quantity 1 plus cosine of 4x. But this is a peel one off. That's one where I'm going to be able to peel one of those off and turn the other into sine. So let's continue here. I know it just seems like we're doing an awful lot. And again, this speaks to my argument that I don't think they're going to have you do this very much, because look how much algebra is going on here. There's a whole stinking lot of algebra going on here, and they're not, when they're testing your algebra skills like this, they're not testing your calculus skills. So there's that substitution. Remember, I started with the double angle already, and so I had to double that when I did the substitution. And now I'm going to peel one of those cosine of 2x's off, cosine of 2x dx. Okay, and then what I'll have left here is the cosine squared of 2x, and so I'm going to use the Pythagorean identity to substitute that. And we could clean it up again. Just a whole lot of algebra going on here. 1 plus cosine of 2x. And then I have minus 1/2 minus 1/2. Gotta watch me. Cosine of 4x. And then minus, I'm going to leave this the way that it is because this is actually going to be done as a u substitution. Cosine of 2x. So all of that is kind of one term that I'm going to do. I have a positive 1 and I have a negative 1/2. So in the interest of getting this all written out like it needs to be, 1 minus 1/2 leaves me a positive 1/2 plus a cosine of 2x, which is going to be a u substitution, minus a 1/2 cosine of 4x, another u substitution technique. And then here we're going to have this u substitution technique where u is going to involve, instead of just what's going on inside of cosine, u is going to involve the sine function. There we go. All right. Let's start doing our antiderivative. So this is 1/8, and I'm integrating, with respect to x. So that's 1/2 x. This is a u substitution, and if you need to write all of this down, then definitely write all of this down. I'm working above here, so I have space. If you need to write all of it down, write all of it down. But you're going to see that this happens a lot. And so you ought to be able, once you work a few of these, you ought to be able to jump right here as the antiderivative of that. And now we're going to have the same kind of idea for this term. There's a 1/2 out front. Now u is 4, so everywhere there's a 2, I'm going to have a 4. So I'll pop that 1/4 out front and multiply it by that 1/2. That gives me a 1/8. And I'm going to have an antiderivative of sine of 4x. Now my u substitution is a little bit different. Now my u substitution is the sine of 2x. So my du on here is going to be 2 cosine of 2x dx. So this would be written as 1 minus u squared du, just this last part down here, but I'm off by a constant. So this is going to be the antiderivative of just that part would be 1/2 u minus 1/3 u cubed plus c. So we're going to write that here, and then we'll finish this out. So this would be minus, I'm copying this minus down there, the quantity 1/2 times the sine of 2x, that's u, minus 1/3 sine cubed of 2x. And then we're done, plus c. So it took us this entire video to do this one example. Let's see, is there... Okay, there's one more example, so I'll have one additional video for this lesson to look at. But you get the idea. You're probably not going to be asked to do even exponents very often.